Good morning, students. In the last class, we discussed about the magnetic field around the current carrying conductor, right? In the last class, we discussed so any conductor which is carrying current, so we can find the magnetic field at any point P at a certain distance or from the current carrying conductor by using the Biot-Savart law, right? So the relation is dP, that is equals to mu naught by 4 pi IDL sin theta divided by R square. So this is the relation for the Biot-Savart law, right? So in the last class we discussed this relation and also we write the magnetic field in vector form. So make a small correction. In the last class we written dB vector, that is equals to mu naught by 4 pi I into, so we can write this in the vector form, ideal sin theta divided by R square into R cap, right? Or we can write this dB vector, that is equals to mu naught by 4 pi I keeping outside, so dl vector cross vector R divided by R cube, right? So make a small correction. In the last class we written I cross dl, so make it that one to I into dl cross R divided by R cube. So in place of R square in the vector form, we will write that as R cube, because R cap is equals to vector R divided by magnitude of vector R, that is equals to vector R divided by R. So in place of R cap we can write vector R divided by R. So R into R square we getting R cube. So this is the vector form for the Biot-Savart's law, right? So idondu correction ಮಾಡ್ಕೊಳ್ಳಿ. So comparison between Biot-Savart law and Coulomb's law, right? So Coulomb's law ನಾವು first chapter ಅಲ್ಲಿ discuss ಮಾಡಿದ್ವಿ, force between the two charges, point charges when they are at rest. So Biot-Savart's law last class ಅಲ್ಲಿ discuss ಮಾಡಿದ್ವಿ, right? So current carrying conductor ಅಲ್ಲಿ ನಾವು ಏನು ಮಾಡಬಹುದು, magnetic field na find out ಮಾಡಬಹುದು. So here comparison between the Biot-Savart's law and Coulomb's law, right? So Coulomb's law we have two charges, that is point charges, either it may be a similar charge or it may be the dissimilar charge, like charges or dislike charges, right? So if we consider two charges are similar, then there is a force of repulsion between the two charges. So these two charges are separated by a small distance r, right? So from the Biot-Savart's law we have the relation dP is equals to mu naught by 4 pi IDL sin theta divided by R square, right? So this is the relation for the Biot-Savart's law, and the relation for the Coulomb's law is F is equals to 1 divided by 4 pi epsilon naught Q1 Q2 divided by R square, right? So idu namge Biot-Savart's law inda bandiro relation, idu namge Coulomb's law. So again this is from the first chapter, so idu ee chapter alli discuss ಮಾಡಿದ್ವಿ. So comparison between the Biot-Savart's law and the Coulomb's law, right? So first is, so similarities between the Biot-Savart's law and Coulomb's law. So the first point is both are long range forces. So the force, so current carrying conductor ಅಲ್ಲಿ ನಮಗೆ ಫೋರ್ಸ್ ಇರುತ್ತೆ, ಸೊ ಇಲ್ಲಿ ನಮಗೆ ಏನು ಫೋರ್ಸ್ ಇರುತ್ತೋ ಸೊ ಅದು ಲಾಂಗ್ ರೇಂಜ್ ಫೋರ್ಸ್, ರೈಟ್? ಸೊ ಡಿಸ್ಟೆನ್ಸ್ ತುಂಬಾ ಡಿಸ್ಟೆನ್ಸ್ ಅಲ್ಲಿ ಇದ್ರೂ ಕೂಡ ಇಟ್ ಅಫೆಕ್ಟ್ಸ್ ಬೈ ದ ಕರೆಂಟ್ ಕ್ಯಾರಿಂಗ್ ಕಂಡಕ್ಟರ್. ಸೊ ಇಲ್ಲಿ ಕೂಡ ಅಷ್ಟೇ, ಸೊ ಒನ್ ಚಾರ್ಜ್ ಪ್ರೊಡ್ಯೂಸಸ್ ದ ಫೋರ್ಸ್ ಆನ್ ದ ಅನದರ್ ಚಾರ್ಜ್. ಸೊ ಹಿಯರ್ ಆಲ್ಸೋ ಇಟ್ ಡಿಪೆಂಡ್ಸ್ ಆನ್ ದ ಡಿಸ್ಟೆನ್ಸ್. ಸೊ ದೀಸ್ ಟೂ ಆರ್ ಲಾಂಗ್ ರೇಂಜ್ ಫೋರ್ಸಸ್, ರೈಟ್? ಸೊ Biot-Savart's law ದಲ್ಲಿ ಏನು ಫೋರ್ಸ್ ಬರುತ್ತೆ, ಸಿಮಿಲರ್ ಟು ದಟ್ ಆಫ್ ದ Coulomb's law ದಲ್ಲಿ ಏನು ಫೋರ್ಸ್ ಬರುತ್ತೆ, ಎರಡು ಕೂಡ ಏನಿರುತ್ತೆ ನಮಗೆ ಲಾಂಗ್ ರೇಂಜ್ forces, right? So the second point is both are related with the square of the, that is inverse square of the distance between the source and to the point, right? So ಇಲ್ಲಿ ನಮಗೆ magnetic field ಏನಿದೆ dB, that is inversely relates with the square of the distance between the source and to the point charge, right? So dB ಯಾವಾಗ ರಿಲೇಟ್ ಆಗಿದೆ ಅಂದ್ರೆ inversely proportional to the square of the distance between the source and to the charge. So ಇಲ್ಲಿ ಕೂಡ ಅಷ್ಟೇ, the force in the Coulomb's law is relates inversely to the square of the distance between the charges, right? So force ಯಾವಾಗ ರಿಲೇಟ್ ಇದೆ ಅಂದ್ರೆ 1 by r square ಗೆ ರಿಲೇಟ್ ಇದೆ. ಇಲ್ಲಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಕೂಡ 1 by r square ಜೊತೆ ರಿಲೇಟ್ ಆಗಿದೆ, right? So second point, ಎರಡರಲ್ಲೂ ಸಿಮಿಲರ್ ಏನಿದೆ ಅಂದ್ರೆ it both are related to the inverse of the square of the distance between the source and to the point, right? Both are relates inversely to the square of the distance between the source and to the point P, or and to the point. So ಎರಡು ಕೂಡ ಏನಾಗುತ್ತೆ inversely square ಆಗಿ relate ಆಗಿರುತ್ತೆ, right? So the next third point are, so in Biot-Savart's law we consider the element, the small element, that is dl. So ಈ small element ನ consider ಮಾಡ್ಕೊಂಡಿದ್ದೀವಿ. So if we want to find the magnetic field produced by the overall length of this conductor, means we need to add all the current elements. So summation of all the current elements gives what? The total current which is flowing in the conductor. So current element andre ಏನು dl into I. So its unit is ampere meter. So current ಒಂದು small element conductor ಅಲ್ಲಿ flow ಆಗ್ತಿದ್ರೆ ಅದನ್ನ current element ಅಂತ ಕರೀತೀವಿ. So ಇಲ್ಲಿ ನಮಗೆ ಏನು current flow ಆಗ್ತಿದೆ ಇಷ್ಟು ಕಷ್ಟ ನಾವು ಫೈಂಡ್ ಔಟ್ ಮಾಡಿರೋದು, that is the small magnetic field dB. So total magnetic field B ಬೇಕು ಅಂದ್ರೆ we need to summation all the current elements. That means here superposition principle ಏನಾಗುತ್ತೆ accept ಆಗ್ತಾ ಇದೆ. So same wise here also, if we have more than two charges, q3, q4, q5, right? So these are the charges. So ಇಲ್ಲಿ ಕೂಡ ಏನಾಗ್ತಿದೆ ನಮಗೆ it relates the forces, right? So ಇಲ್ಲಿ ಕೂಡ act ಆಗ್ತಿದೆ. So superposition of all the charges, that is summation of the forces of all the charges ನ ನಾವು superposition principle. So ಇದನ್ನ first chapter study ಮಾಡಿದ್ವಿ. So same superposition is applicable in this case also. So to find the total magnetic over the length of the conductor, so we need to summate, that is adding of all the current elements. So adding of all the current elements means, so from here we getting magnetic field. So from all these current elements getting the magnetic field. So total magnetic field is obtained by adding all the current elements, right? So that means superposition principle is acceptable in both the cases, right? That is principle of superposition is applicable for both the cases, right? So these are the three similarities between the Biot-Savart's law and Coulomb's law. So ಎರಡರಲ್ಲೂ ಏನು similarities ಇದೆ ಅಂದ್ರೆ, first similarities are both are long range forces. So ತುಂಬಾ distance ಅಲ್ಲಿ ಇದ್ರೂ ಕೂಡ force ಏನಾಗ್ತಿದೆ ಅದ್ರ ಮೇಲೆ act ಆಗ್ತಾ ಇರುತ್ತೆ, right? So the second point is both are relates inversely to the square of the distance. So a point charges, ನಾವು ಯಾವ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ force calculate ಮಾಡ್ತಿದೀವಿ ಅಥವಾ ಯಾವ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ magnetic field ನ find out ಮಾಡ್ತಿದೀವಿ ಅಂದ್ರೆ ಆ ಪಾಯಿಂಟ್ ಮತ್ತೆ ಆ source ಮಧ್ಯದಲ್ಲಿ ಇರೋ distance inverse ಆಗಿ relate ಆಗಿರುತ್ತೆ, that is 1 by r square. So this we can write dB is inversely proportional to 1 by r square. So same here also, force is inversely proportional to 1 by r square. So ಇಲ್ಲಿ magnetic field ಇದೆ. So ಇಲ್ಲಿ ನಮಗೆ ಸಿಗ್ತಾ ಇರೋದು ಯಾವುದು electric field. So electric field is also inversely proportional to 1 by r square, right? So magnetic field and electric field both relates inversely to the square of the distance between the two point charges, or distance between the current element and to that of the point source, that is point, right? So these are the three similarities between the Biot-Savart's law and Coulomb's law. right? So next, differences. Differences between Biot-Savart's law and Coulomb's law. So first difference. So first difference, here is the source of the magnetic field. So here the magnetic field is producing, the source of the magnetic field is the current element, that is IDL. IDL is the source of the current element. So this is the vector, right? So IDL another, this is vector component, right? So here in case of Coulomb's law, both the charges Q and Q2, Q1 and Q2, or you can consider any one charge. So ಯಾವುದಾದ್ರೂ ಒಂದು ಚಾರ್ಜ್ ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ, so this charge is the source. So ಈ ಚಾರ್ಜ್ ಇಂದ ನಮಗೆ ಏನು ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತಿದೆ, ಫೋರ್ಸ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತಿದೆ, and the same way electric field ಕೂಡ ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತಿದೆ, right? The source of the Coulomb's law, so this charge is the source, so this is the scalar quantity. So here the source is the current element, so this one is the vector quantity, right? So difference ಏನಿದೆ ಅಂದ್ರೆ ನಮಗೆ source magnetic field produce ಮಾಡೋದಕ್ಕೆ source ಏನಿದೆ ಅದು current element. So ಆ current element ನಮಗೆ vector quantity ಇರುತ್ತೆ. So ಇಲ್ಲಿ ನಮಗೆ electric field produce ಮಾಡೋದಕ್ಕೆ source ಯಾವ್ದಿದೆ, that is the charge. So charge ಏನಿದೆ ನಮಗೆ scalar quantity, right? So source of magnetic field ಗೆ source ಯಾವುದು ಅಂದ್ರೆ that is the current element is a vector quantity. So this one is the first difference. So magnetic field ಯಾವ್ದ್ರಿಂದ ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತಿದೆ, current element ಇಂದ ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತಿದೆ. So that current element is a vector quantity, right? So in Coulomb's law, source of electric field. So source of electric field ಯಾವ್ದಿದೆ ನಮಗೆ Coulomb's law ದಲ್ಲಿ, that is the charge. So charge is a scalar quantity, right? So next, second difference is, so the magnetic field which is produced in the Biot-Savart's law, this is the current element BL and I is the current. So charge Q1, so in the force direction we have the electric field, right? So next difference is we are going to find the magnetic field, right? So in the last we denoted with the cross symbol. Cross symbol means magnetic field is going in the direction perpendicular to the plane of the paper or plane of the board. So in board ge inside agi ಏನು ಹೋಗ್ತಾ ಇದೆ ನಮಗೆ magnetic field ಮೂವ್ ಆಗ್ತಿದೆ. But current element ಮತ್ತೆ magnetic field ಎರಡು ಕೂಡ ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇರುತ್ತೆ, ನಮಗೆ perpendicular direction ಅಲ್ಲಿ ಇರುತ್ತೆ, right? So current element ಗೆ ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ನಾವು ಡ್ರಾ ಮಾಡಿದ್ರೆ, so this cross indicates what the magnetic field is going inside to the plane of the board. That means the angle between the current element and to that of the magnetic field is always 90 degrees. Right? So that means the magnetic field is perpendicular to that of the current element in the plane which we are considering the current element. So ನಾವು ಯಾವುದಾದ್ರೂ ಒಂದು plane ಅಲ್ಲಿ current element ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ, so ಅದಕ್ಕೆ perpendicular ಆಗಿ ಏನು ಹೋಗ್ತಾ ಇರುತ್ತೆ ನಮಗೆ magnetic field ಹೋಗ್ತಿರುತ್ತೆ. So that is also depend on the current I. So I ಈ direction ಅಲ್ಲಿ ಹೋಗ್ತಾ ಇದ್ರೆ, in the upward direction ಅಲ್ಲಿ ಹೋಗ್ತಾ ಇದ್ರೆ, so magnetic field ಕೂಡ ಏನಾಗುತ್ತೆ inside the board ಹೋಗುತ್ತೆ. So if we change the direction of the current, then it come out of the board. So board in the ಹೊರಗಡೆ direction ಅಲ್ಲಿ ಏನು ಬರುತ್ತೆ, current ಬರುತ್ತೆ. So that is the magnetic field ಬರುತ್ತೆ. So that is depends on the current direction. So ಎರಡು ಕೇಸ್ ಅಲ್ಲಿ ಏನಿರುತ್ತೆ ನಮಗೆ perpendicular ಆಗಿ ಆಕ್ಟ್ ಆಗ್ತಿರುತ್ತೆ. But in case of the charge, so electric field produce ಆಗ್ತಿದೆ. So electric field produce ಆಗ್ತಿದೆ ಅಂದ್ರೆ electric field is always along the direction of the force. That means in the direction of the ಚಾರ್ಜ್. ಸೊ ನಮಗೆ ಚಾರ್ಜ್ ಯಾವ ಪ್ಲೇನ್ ಅಲ್ಲಿ ಇರುತ್ತೋ ಸೊ ಅದೇ ಪ್ಲೇನ್ ಅಲ್ಲಿ ನಮಗೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಕೂಡ ಏನಾಗ್ತಿರುತ್ತೆ ಆಕ್ಟ್ ಆಗ್ತಿರುತ್ತೆ. ಬಟ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಏನಿರುತ್ತೆ ಆಲ್ವೇಸ್ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್. ಸೊ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇಸ್ ಆಲ್ವೇಸ್ ಪ್ಯಾರಲಲ್. ಪ್ಯಾರಲಲ್ ಮೀನ್ಸ್ ಇನ್ ದ ಸೇಮ್ ಪ್ಲೇನ್. ಸೊ ಚಾರ್ಜ್ ನಾವು x ಪ್ಲೇನ್ ಅಲ್ಲಿ ಇಟ್ರೆ ಸೊ x ಆಕ್ಸಿಸ್ ಅಲ್ಲಿ ಇಟ್ರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಕೂಡ ಅಲಾಂಗ್ x ಆಕ್ಸಿಸ್ ಇರುತ್ತೆ. y ಆಕ್ಸಿಸ್ ಅಲ್ಲಿ ಇಟ್ರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇಸ್ ಅಲಾಂಗ್ y ಆಕ್ಸಿಸ್ ಅಲ್ಲಿ ಇರುತ್ತೆ. ಸೊ ದಟ್ ಮೀನ್ಸ್ ಇನ್ xy ಪ್ಲೇನ್ ಅಲ್ಲಿ ಇಟ್ರೆ ಸೊ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಕೂಡ xy ಪ್ಲೇನ್ ಅಲ್ಲಿ ಇರುತ್ತೆ. ದಟ್ ಮೀನ್ಸ್ ಪ್ಯಾರಲಲ್ ಆಗಿರುತ್ತೆ. But magnetic field is always perpendicular to the source. That means current element ge magnetic field always perpendicular irutte. Either it may move inside the board or it comes away from the board. So inside board ಗಾದ್ರು ಹೋಗಬಹುದು ಅಥವಾ ಹೊರಗಡೆ ನಾದ್ರು ಬರಬಹುದು. But ಎರಡು ಕೇಸ್ ಅಲ್ಲಿ ಏನಿರುತ್ತೆ ನಮಗೆ perpendicular ಆಗಿ ಇರುತ್ತೆ. But in case of Coulomb's law the electric field is always parallel. Parallel means in the same plane. So charge ಯಾವ ಪ್ಲೇನ್ ಅಲ್ಲಿ ಇರುತ್ತೋ ಸೊ ಅದೇ ಪ್ಲೇನ್ ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇರುತ್ತೆ. ಬಟ್ ಇಲ್ಲಿ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿರುತ್ತೆ. ಸೊ ದಟ್ ಇಸ್ ದ ಸೆಕೆಂಡ್ ಡಿಫರೆನ್ಸ್ ಬಿಟ್ವೀನ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ದಟ್ ಇಸ್ Coulomb's law to the Biot-Savart's law, right? So magnetic field always acts perpendicular to the source element, right? So here the electric field always acts in the direction of source, right? So source ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇರುತ್ತೆ ನಮಗೆ electric field ಕೂಡ ಅದೇ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇರುತ್ತೆ. But in case of magnetic field it is perpendicular to the source. So source ಅಂದ್ರೆ always remember that one is the current element, that is I into dm. So current flowing in a small length of the conductor, so that we call as the current element, and its SI unit is ampere meter. So ಇದು ನಮಗೆ SI unit ಆಗಿದೆ, right? So on the last point is, so if you observe the magnetic field relation, so here one term is there, that is the angle theta. So that means the magnetic field depends on the angle theta. So theta theta is the angle between the current element and to the point where we are going to find the magnetic field. So now current element in the one line na draw madidre. So angle is formed between the current element and to the line joining the point from the source, right? So dB is directly relates with the sign of the angle between the current element and to the is independent of angle theta, right? So this is the comparison between Biot-Savart's law and Coulomb's law. So you three similarities ಇದೆ, three dissimilarities ಅಥವಾ differences ಇದೆ, right? So this is about the comparison. So comparison ಅಲ್ಲಿ ನಾವು mainly by using the formula, so ಎರಡು formulas ನ ಇಟ್ಕೊಂಡು ಕಂಪೇರ್ ಮಾಡ್ತೀವಿ, right? So next, so important derivation ಇದೆ. Magnetic field on the axis of circular loop. So ಇಲ್ಲಿ circular loop, circular coil, circular conductor, so ಏನ್ ಮೆನ್ಷನ್ ಮಾಡೋದು ಕೂಡ, so we are going to find the magnetic field. So very important for 5 marks. So ತುಂಬಾ important ಇದೆ. So in the previous class we have discussed about the magnetic field. We are finding the magnetic field only for the current carrying conductor. So the ಯಾವ shape ಅಲ್ಲಿ ಕೂಡ we find the magnetic field at any point around this conductor. So starting ಅಲ್ಲಿ ಯಾವುದಾದ್ರೂ ಒಂದು ಕಂಡಕ್ಟರ್ ಅಲ್ಲಿ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ತಿದೆ ಅಂದ್ರೆ it produces the magnetic field. So we need to find the strength of the magnetic field at any point, right? So that point may be at any distance from the conductor. So ಯಾವುದಾದ್ರೂ ಒಂದು distance ಅಲ್ಲಿ we find the magnetic field, and that magnetic field is perpendicular to the current element, right? So ಅದನ್ನು ಕೂಡ last class ಅಲ್ಲಿ discuss ಮಾಡಿದ್ವಿ, that is by using the Biot-Savart's law. So here the special case is we are going to find the magnetic field on the axis of the circular loop, that means circular conductor. So ಇದು irregular shape conductor ಅಲ್ಲಿ ನಾವು find out ಮಾಡಿದ್ದು magnetic field dB, that is equals to mu naught by 4 pi IDL sin theta divided by r square. So ಈ ರಿಲೇಶನ್ ಸಿಕ್ಕಿದ್ದು ಯಾವುದಕ್ಕೆ ಅಂದ್ರೆ for an conductor which is carrying current, so often regular or irregular shape. So ಯಾವುದೋ shape ಅಲ್ಲಿ ನಾವು magnetic field find ಮಾಡಿದ್ವಿ at a particular point at a distance or from the source. So ಈ distance ಅಲ್ಲಿ ನಾವು magnetic field find ಮಾಡಿದ್ದಕ್ಕೆ we get the relation, that is the Biot-Savart's law, right? So now we are going to find the magnetic field on the axis of the circular loop. That means we need to consider the circular coil or circular conductor, right? So vertical circle draw ಮಾಡಿದ್ರೆ that it should be in the ellipse form ಅಲ್ಲಿ ಇರುತ್ತೆ. So this is the vertical circle. So there is a difference in horizontal and vertical. So this coil is placed in YZ plane, right? So again by drawing the coordinate axis X, Y, Z, right? So considering the coil of a circular coil which is placed in an YZ plane, right? So YZ plane ಅಲ್ಲಿ ನಾವು circular coil ನ consider ಮಾಡಿದ್ವಿ. So the current is flowing in the circular coil, where I is the current which is flowing in the circular coil. So we need to find the magnetic field on the axis of the circular loop. So ಇದು circle ಇದೆ ಅಂದ್ರೆ on the axis ಅಲ್ಲಿ ನಾವು ಏನು find out ಮಾಡಬೇಕು, magnetic field find out ಮಾಡಬೇಕು. So naming point P where we are going to find the magnetic field at a distance x from the center of the circular loop, right? So O is the center of the circle. So x distance ಅಲ್ಲಿ ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ನಾವು ಏನು ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತಾ ಇದೀವಿ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತಾ ಇದೀವಿ. ಸೊ ದಟ್ ಈಸ್ ದ ಕ್ವೆಶ್ಚನ್, ಟು ಫೈಂಡ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಆನ್ ದ ಆಕ್ಸಿಸ್ ಆಫ್ ದ ಸರ್ಕ್ಯುಲರ್ ಲೂಪ್. ಸೊ ದಿಸ್ ಇಸ್ ದ ಆಕ್ಸಿಸ್ ಆಫ್ ದ ಸರ್ಕ್ಯುಲರ್ ಲೂಪ್. ಸೊ ಎಕ್ಸ್ ಎಕ್ಸ್ ಡ್ಯಾಶ್ ಅನ್ನೋದು ಆಕ್ಸಿಸ್ ಆಗಿರುತ್ತೆ ಸರ್ಕ್ಯುಲರ್ ಲೂಪ್ ಗೆ. ಆನ್ ದಟ್ ಆಕ್ಸಿಸ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಫೈಂಡ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅಟ್ ಎನಿ ಪಾಯಿಂಟ್ P at a distance x from the center of the coil, right? So now considering the current element. So previous now Biot-Savart's law dallu kuda now considered madidvi where dl is the current element. So here considering AB is the current element, right? So this is dl. So the vector irodrinda, so the direction is perpendicular to the current element. So current element ge perpendicular agi direction alli dl irutte. So again considering here one more current element A dash B dash of same length, that is dl. So direction inverse. So idu kuda depend yaudr mele agtirutte namage current flowing. So ee direction alli current flow agtide perpendicular ee direction alli irutte. So current ee direction alli irodrinda opposite direction to the initial. So ಇಲ್ಲಿ current opposite ಇರೋದ್ರಿಂದ dl ಕೂಡ ಏನಿರುತ್ತೆ ನಮಗೆ opposite ಇರುತ್ತೆ, right? So next considering vector r. So idu vectors irodrinda we need to be careful, right? So Biot-Savart's law dalli where dl and r are perpendicular to the each other, right? So from Biot-Savart law, so vector form alli represent ಮಾಡ್ಕೊಂಡ್ರೆ vector db, that is equals to mu naught by 4 pi I into dl cross r divided by r cube. So calling this one as first equation, right? So dl and r, these two are perpendicular to each other, right? So current element ಮತ್ತೆ R. So last Biot-Savart's law we find out that dl is the element. So somewhere here we are going to find the magnetic field. So line joining between the current element and to the P we taken, that is the angle theta, right? So Biot-Savart's law magnetic field is directly relates with the sign of the angle between the current element and to the line joining the source to the point P, right? So here also angle theta is the angle between the current element and to the line joining point P. So ಇಲ್ಲಿ ನಾವು current element considered ಮಾಡಿರೋದ್ರಿಂದ so ಈ angle ಅನ್ನು ನಾವು ಏನಂತ consider ಮಾಡ್ತಿದೀವಿ theta, where theta is the angle between the current element and to that of the magnet point P. So magnetic field in the last class also, now also I said about it is perpendicular to the current element, right? So magnetic field ಯಾವಾಗಲೂ perpendicular ಇರುತ್ತೆ. So ಆ ಡೈರೆಕ್ಷನ್ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ಕೊಂಡ್ರೆ so dB is perpendicular to vector R. So magnetic field is always perpendicular to that of the current element. So that is it is moving inside the plane of the paper or plane of the board. So adana represent ಮಾಡ್ಕೊಂಡ್ರೆ it is in the direction. So ಇದು 3 dimension ಇರೋದ್ರಿಂದ little bit confuse ಆಗುತ್ತೆ. So it represents what the magnetic field is moving inside the board. So board ಒಳಗಡೆ ಹೋಗ್ತಾ ಇದೆ ಅಂತ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. That means z axis ಅಲ್ಲಿ ಏನಾಗ್ತಿದೆ ನಮಗೆ magnetic field ಹೋಗ್ತಿದೆ. So z axis means ಇದನ್ನ ಎಕ್ಸ್ಟೆಂಡ್ ಮಾಡಿದ್ರೆ so z axis is parallel to that of the dB, right? So now it makes an angle theta with the horizontal. So now we can resolve this dB along x axis and along y axis, right? So along x axis again by resolving the vector component along x axis and along y axis. So theta along x axis irodinda so this becomes dB cos theta. So along y component dB sin theta, right? So it is to diagram. So ಕೆಲವು ಕಡೆ ನಮಗೆ angle theta ಇಲ್ಲಿ ಕನ್ಸಿಡರ್ ಮಾಡಿರ್ತಾರೆ. That means angle theta with the vertical considered ಮಾಡಿರ್ತಾರೆ. So ಇಲ್ಲಿ angle theta ಇದ್ರೆ here it becomes an angle theta. So ನೀವು ಯಾವುದನ್ನ ಬೇಕಿದ್ರು ರೆಫರ್ ಮಾಡಬಹುದು, ಬಟ್ NCERT ಅಲ್ಲಿ ನಮಗೆ ಕೊಟ್ಟಿರೋದು theta makes an angle with the horizontal, right? So as I said, DL and R are perpendicular to each other. So this current element and the line joining from the current element to the point P are these two are perpendicular, right? So these two are perpendicular means writing the dP that is equals to mu naught by 4 pi I dl sin theta divided by r square, right? So now dl is perpendicular to r, that means angle theta is equals to 90 degree. So sin 90 degree is equals to 1. So this relation becomes dB that is equals to mu naught by 4 pi I dl divided by r square. So calling this one as second equation, right? So ಇಲ್ಲಿ current element ಮತ್ತೆ r these two are perpendicular ಇರೋದ್ರಿಂದ so sin theta value ಏನಾಗುತ್ತೆ 1 ಆಗುತ್ತೆ. So 1 into I dl by r square, so we get mu naught by 4 pi I dl by r square. So this is the small magnetic field across this current element. So ಇಲ್ಲಿ ನಮಗೆ ಬಂದಿರೋ magnetic field ಯಾವಿದೆ dB. This is due to only the small current element. So we need to find the total magnetic field due to this entire circular loop, right? So you observe model we are considering only the small element dl, that's why we are getting the small magnetic field dB. So overall current element ke now consider overall circular loop ye consider madidre we getting the total magnetic field that is B, right? So here we have the two components of the magnetic field. So those two components will be taken as Bx is the magnetic field along the x component. So vector Bx that is equals to B cos theta into I cap, right? So and by vector is equals to b sin theta into j cap. So these are the two magnetic field components along x-axis and along y-axis. So b cos theta is the magnitude and I cap is the direction. So b cos theta magnitude along x-axis, b sin theta is the magnitude along y-axis. So aduna illi represent along x-axis, along y-axis, right? So here also small magnetic field for the small current element. So dB sin theta ಅನ್ನೋದು ಏನಿದೆ ನಮಗೆ small magnetic field only due to the small element dl, right? So for complete circuit loop ಗೆ consider ಮಾಡಿದ್ರೆ we need to summation of all the current elements. Summation means by adding all the small current elements, so we get the total magnetic field across the circular loop, right? So if we summate all the current elements, right, which is perpendicular to x-axis, that is dB sin theta. So iduna add madidre enagutte, we get 0 because this circle is diametrically symmetry. So diametrically opposite ಏನಿದೆ ನಮಗೆ symmetry ಇದೆ. So as dB sin theta vertical component ಅಲ್ಲಿ upper half ಅಲ್ಲಿ ಏನೇನ್ current element ಬರುತ್ತೋ ಅದೆಲ್ಲವೂ ಯಾವ್ದ್ರಲ್ಲಿ ಇರುತ್ತೆ ನಮಗೆ ಪಾಸಿಟಿವ್ ವ್ಯಾಲ್ಯೂ ಅಲ್ಲಿ ಇರುತ್ತೆ dB sin theta. So ಬಾಟಮ್ ಅಲ್ಲಿ ಬರೋದು that means diametrically ಈ ಆಕ್ಸಿಸ್ ಇಂದ ಕೆಳಗಡೆ ಬರೋ ಕರೆಂಟ್ ಎಲಿಮೆಂಟ್ಸ್ ಎಲ್ಲ ನಮಗೆ ಯಾವ್ದ್ರಲ್ಲಿ ಬರುತ್ತೆ ನೆಗೆಟಿವ್ ಅಲ್ಲಿ ಬರುತ್ತೆ. ಸೊ ದಟ್ ಮೀನ್ಸ್ ಆಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಇರೋದ್ರಿಂದ ಏನಾಗುತ್ತೆ ನಮಗೆ 0 ಆಗುತ್ತೆ. ದಟ್ ಮೀನ್ಸ್ ಸಮೇಷನ್ ಆಫ್ ಆಲ್ ದ ಕರೆಂಟ್ ಎಲಿಮೆಂಟ್ that is magnetic field along vertical components becomes 0. So only component we are getting adding, that one is the dB cos theta. So only x-axis ಅಲ್ಲಿ ಬರೋ components ನ add ಮಾಡಿದ್ರೆ we getting the total magnetic field, right? So net magnetic field P is, so ಇಲ್ಲಿ net magnetic field is the net means total magnetic field at the point we have two components along x-axis component and along y-axis component, right? So along x-axis component we can write that one as dBx, summation of dBx. So summation means adding of all the magnetic field along the vertical component. So vertical component ಅಲ್ಲಿ ಬರೋ ಎಲ್ಲ elements ನು ಕೂಡ ನಾವು add ಮಾಡಿದ್ರೆ we get dBx, that is equals to summation of b cos theta, right? So this first we will take dB by along y-axis. So summation of b sin theta and that is equals to 0, right? Because by is diametrically symmetry so by ಏನಿದೆ ನಮಗೆ diametrically symmetry ಇದೆ. So upper half of the axis ನಮಗೆ ಏನು by components ಬರುತ್ತೋ, so lower half of by components opposite sign ಅಲ್ಲಿ ಇರುತ್ತೆ. So ಎರಡನ್ನೂ ಆಡ್ ಮಾಡಿದ್ರೆ plus dB sin theta minus dB sin theta, so get cancels ಆಗುತ್ತೆ. So hence dB y component ಏನಿರುತ್ತೆ ನಮಗೆ 0 ಬರುತ್ತೆ, right? So only component which we are getting the magnetic field, that is summation along the x axis, right? So net magnetic field at point P is summation of dBx, that is equals to summation of b dB sin theta. So ಇಲ್ಲಿ dBx ಅಂದ್ರೆ ನಮಗೆ dB sin theta into I cap. right? So dB के value होती है, so summation of dB here, so substitute here, its component ಯಾವುದು ಇದೆ ನಮಗೆ cos theta ಇದೆ, so dB cos theta into I cap, right? So substituting the value of dB, that is mu naught by 4 pi I dl divided by r square into cos theta I cap, right? So from this triangle, so AB or AOP, from triangle AOP, cos theta is equals to, so this is the angle theta, so it is also the right angle triangle, so cos theta is equals to adjacent side by hypotenuse. So considering here r is the radius of the circle, that is capital R, right? So cos theta is equals to r divided by r, right? So again, by applying the Pythagoras theorem, so r is equals to sum of r square plus x square, right? So cos theta is equals to r divided by r square plus x square, that is hypotenuse is equals to sum of the other two sides, that is r square plus x square, right? So now substituting the value of cos theta, later we can substitute the r value. So first substitute cos theta is equals to r divided by r, so summation of mu naught by 4 pi I dl divided by r square into cos theta value is r divided by r I cap, right? So I cap indicates for the direction along x axis, so that is equals to summation of mu naught by 4 pi I dl r divided by r cube into I cap, right? So again from the same triangle AOP, r is equals to, from the Pythagoras theorem, r square plus x square whole to the power of 1 by 2. So that is r square is equals to r square plus x square. So in place of r we can substitute r square plus x square, right? So taken common outside mu naught by 4 pi I r square plus x square whole power 3 by 2 into summation of dl, that is dB. So up to here we getting the small magnetic field due to the small current element. So here we need to summate all the current element, that is dl. So that is dB is equals to mu naught by 4 pi I r divided by r square plus x square whole power 3 by 2. So summation of dl. So dl is the current element. So we taken this one as the circular loop of radius r. So summation of dl means it will use the circumference of the circle. So circumference of the circle is 2 pi r, where r is the radius of the circle. So summation of dl ಏನು ಕೊಡುತ್ತೆ ಅಂದ್ರೆ, so ಎಲ್ಲ small current elements na add ಮಾಡಿದ್ರೆ it is in the form of a circle, so it gives the circumference of the circle. So circumference of the circle formula is 2 pi r, right? So 2 pi, so here 4 pi get cancelled, so we getting 2, so we get the total magnetic field is B. So summation irodrinda, if we remove the summation, we get the total magnetic field B, that is equals to mu naught by 2 I r square divided by r square plus x square whole power 3 by 2 I cap. So this is the total magnetic field for the circular loop, right? So ಇಲ್ಲಿ ಕೂಡ summation ಇದೆ. So summation dB, summation dB, summation dB, right? So at the center of the loop. So at the center of the loop means, So exactly at the center of the circle, that means x value ಏನಾಗುತ್ತೆ ನಮಗೆ 0 ಆಗುತ್ತೆ. Because we considering point at the center of circle, so P lies on the center of the circle, then at the center of the loop x is equals to 0. So substitute x is equals to 0, so we get magnetic field P is equals to mu naught I r square divided by 2 into, so r square plus 0 r square, so square and square get cancelled, we get r cube. So r square r cube get cancelled, so we get magnetic field B is equals to mu naught I by 2 r. So this is the condition when at the center of the circle, that is at x is equals to 0, right? So ಇದು derivation ತುಂಬಾ important derivation. So consider one circular loop of radius r. So we need to find the magnetic field at a point P on the axis of the circular loop at a distance x from the center, right? So now consider the current element is perpendicular to the radius vector or the distance vector from the current element onto the point P. That means dl is perpendicular to r, so sin theta is 90 degree, that is value 1. We getting the sin value is 1, right? So we getting the magnetic field, it is also perpendicular to that of the two components dl ಮತ್ತೆ r ಗೆ perpendicular ಆಗಿರುತ್ತೆ, because these two are the cross product, right? So this element we can consider or resolve into two components, one is along horizontal and another one is along vertical. So summation of the vertical component we get the 0 value because it is diametrically symmetry ಆಗಿರೋದ್ರಿಂದ, so upper ಅಲ್ಲಿ ಏನು values ಬರುತ್ತೆ positive ಅಲ್ಲಿ, so below the axis are ಕೂಡ negative but magnitude same ಇರುತ್ತೆ. So summation ಮಾಡಿದ್ರೆ plus dB sin theta minus dB sin theta get cancelled, so only the component of the magnetic field which we are getting along the x axis. So along the x axis we need to find the total magnetic field. So ಇದನ್ನ small element ನ total add ಮಾಡಿದ್ರೆ, this is in the form of a circle, so substitute ಮಾಡಿದ್ರೆ ನಮಗೆ circumference of the circle formula substitute ಮಾಡಿದ್ರೆ we get the relation. So example ಕೇಳಿದ್ರೆ up to here is the final expression, right? So B, so in case at the center of the loop ಅಂತ ಕೇಳಿದ್ರೆ again we need to extend up to here, right? So this is the derivation. So ಈ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ಇದು ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ derivation, right? So remaining continue part we will discuss in our next class. Thank you.